Hello students, कैसे हो आप सब? चलो, today we are going to learn a very important topic from your Unit 9, Ray Optics. The topic is refraction at spherical surfaces and by lenses. Now this idea is the key to understanding how everything from your spectacles to giant telescopes works. So let's get started, and I promise we'll make it so simple and exam safe that you will never forget it.
Okay, so let's start with something really interesting. You can call it a little bit of magic. Just imagine this for a second. There's a glass lens and you drop it into a beaker full of some transparent liquid, and poof, it just vanishes. How is that even possible? And this isn't just a magic trick. It's an actual question from your NCERT textbook, example 9.6. So keep this mystery in your mind as we go along. Now, to understand this magic, we first need to uncover the secret behind it. And that secret is all about how light bends.
You know, this whole idea of refraction is actually very simple. Socho there's a car driving on a nice smooth road. Suddenly, its right wheels go into a muddy field. Ab kya hoga? The right wheels will slow down, right? But the left wheels are still on the fast road. Because of the speed difference, the car will naturally turn or bend towards the muddy side. Light behaves in the exact same way. When it goes from a fast medium like air to a slower medium like glass, it bends. Bas, that's it. That is refraction.
Now, for your exams, we need to convert this idea into a formula. And for refraction happening at a single curved surface, there is one golden formula that you must remember. It's the key to this entire topic.
Before I show you the formula, let's meet the main players in our story. Look at this diagram. It's straight from your NCERT book. We have an object O, we have its image I, and we have C, which is the center of the sphere this surface is a part of. We call it the center of curvature. And light is traveling from medium 1, which has a refractive index N1, into medium 2 with refractive index N2. Simple enough, right?
And here it is, the formula for refraction at a single spherical surface. N2 by V minus N1 by U is equal to N2 minus N1, the whole thing divided by R. Write this down right now. Put a big box around it. This is a 5-star guaranteed exam formula, bach. Lekin, a formula is useless if we don't know how to use it, na? And the most important part here is the sign convention. Let's break it down. First rule, all distances are measured from the pole, which is the center of the surface. Second, we take the direction of the incident light as positive. So U, the object distance, is almost always negative because we have to travel against the light to measure it. V, the image distance, is positive if it forms on the other side. R, the radius, is positive if the center C is on the right side. And for N1 and N2, please remember this simple trick. N1 is where the light is coming from, and N2 is where the light is going into. Getting these signs right is everything. It's the difference between full marks and 0.
Okay, so we've cracked a single surface. But what is a lens? A lens is nothing, yar. It's just two of these spherical surfaces stuck together. So if we know the formula for one, we can just use it 2 times to understand a whole lens. Look at this diagram from your textbook. It explains the process so beautifully. A ray from the object O hits the first surface and bends. Now, if the second surface wasn't there, it would have formed an image at I1. But wait, before it can do that, it hits the second surface. So this temporary image, I1, it now acts like a virtual object for the second surface. And the second surface then forms the final, real image at I. It's a fantastic 2-step process.
So you see the logic? It's a simple step-by-step process. First, we apply our golden formula for surface number 1 to find where the temporary image I1 is. Then, we treat this I1 as the object for surface number 2 and apply the formula again. And when we combine the 2 equations, we get a brand new, very powerful formula. And this is that formula. It's called the lens maker's formula. The name itself tells you what it's for, right? It's used by the people who actually design and make lenses. It connects the focal length f of a lens with the material it's made of and the curves of its 2 sides, R1 and R2.
And if we simplify that lens maker's formula, we get our hero formula, the one you'll use all the time for solving problems, the famous thin lens formula. 1 by V minus 1 by U equals 1 by F.
Chalo, bahut theory ho gayi. Let's apply what we've learned and solve a simple example from your NCERT book. This will really boost your confidence.
Okay, so the problem says we have light coming from a point source in air and it's hitting a glass surface. First step, always, Write down what is given with the correct signs. That is most important. So, object distance u is negative 100 centimeters. The surface is convex, so radius r is positive, plus 20 centimeters. Light is coming from air, so N1 is 1. It is going into glass, so N2 is 1.5. And we have to find V. Now we just put these values into our golden formula for a single surface. Very carefully, okay? So N2 is 1.5, so we have 1.5 by V, then minus N1 is 1, and U is negative 100, so we have 1 by negative 100. On the right side, it's N2 minus N1, that's 1.5 minus 1, divided by R, which is plus 20. See that? The minus sign with U and the minus in the formula make it a plus. You have to be super careful with these small details.
And after a little bit of simple calculation, we get the answer V is equal to plus 100 centimeter. So, what does this plus sign tell us? It means the image is formed 100 centimeter away on the right side of the surface in the same direction as the light. This means it's a real image. Dekha? It's really that simple once you get the hang of it.
All right, now for what I think is the most important part of this lesson. Let's talk about the common mistakes, the silly errors that students make in exams. I call them silent killers because they silently eat up your marks. Mistake number 1, forgetting the sign of R2. For a normal convex lens, R1 is positive, but students forget that for the second surface, the center is on the left side, so R2 is negative. Always draw a small diagram to check. Mistake number 2, confusing N1 and N2 for the second surface. Remember, for the second surface, light is going from glass back into air, so for this step, N1 is 1.5 and N2 is 1. The roles get reversed. And the third and most common mistake, using the mirror formula, which has a plus for a lens. Just remember this trick. Lens has an N and minus has an N, so lens means minus. The lens formula must have a minus sign. Okay, we're almost at the finish line. Let's quickly summarize the most important points from today's lesson so they stick in your mind. First of all, why is this so important to learn? Because without understanding how lenses bend light, you can't understand how a microscope shows you tiny cells, or how a telescope lets you see faraway planets. This is the fundamental building block of optics. So for a super quick revision, 1, light bends because its speed changes, just like that car in the mud. 2, the single surface formula is your master key for all these problems. 3, a lens is just 2 of these surfaces working as a team. And 4, the most important point of all, sign convention is everything. Practice it, and practice it some more until it becomes automatic for you. Got it? And finally, let's come back to our magic trick. We now know the lens disappeared because the refractive index of the liquid was the same as the lens, so light didn't bend at all. It just passed straight through as if the lens wasn't there. I have a question for you to think about. What would happen if the liquid's refractive index was higher than the glass lens? Would a converging lens, which normally focuses light, still do the same thing? Or would it do something completely opposite? Think about it using the formulas we learned today. We'll see you in the next one.